Okay, so today we are talking about binomial random variables, and we're going to start with this example, which is a pop quiz. So if you were in class, we had you go ahead and take guesses. It's like, it is time for a pop quiz. We hope you're ready. The quiz consists of 10 multiple choice questions. Here they are. Each question has 5 answer choices labeled A through E. Now for the bad news, you will not get to see the questions. You have to just guess the answer. So what are the chances you pass? So you guys went ahead and you took your guesses, and then we scored. And I think the highest that anyone had, without looking at the key, was like 5 or 6 correct. And we did have some people with 0 correct. So you would basically write that down. Now, in a binomial distribution, it helps to know. So I used an example of drawing cards. And let's say I had 4 cards, an ace, a spade, a club, and a diamond. And I go up to a student and I ask them, okay, if you draw a card, then you get a cookie. If you draw a heart, then you get a cookie, right? So we actually did that with some of the tables, and I think I would have 1 or 2 kids out of 4 get it correct, assuming I put the card back. Now, if I didn't put the card back for each new student, then it would change. So I'll talk about that in a second. So first of all, if I told you I was playing this game with 24 students, how many cookies would I expect to give away? And most of you figured out, oh, it's 1 out of 4 of the 24, so I would expect to give away 6 cookies. So that gets to what is the random variable we are measuring. It is the number of successes. So in this case, it is the number of successes, and here it is the number of questions answered correctly. All right, number of questions answered correctly. So what does it mean that the trials of our experiment are independent? So basically that means that your guess, my guess, on one question does not affect my guess on the next answer. So it's very important that the trials are independent and that the probabilities stay the same. So that's why I was talking about putting the card back in, because if I go to a table 4 with the 4 cards, someone for sure will win the cookie, and it'll depend on what the previous person draws. So that would not be independent. But if I put the card back in every time, then I'm back to my same 4 cards, and the probability stays the same. So the probability stays the same. All right? So is it possible for the probability of success to change from one question to the next? No, we actually, I guess I could have written it down here. The probability of success must be the same for each trial. All right? So those cannot be changing. All right? Now, we're going to go ahead and set up the model for this. So the good news is there's a big fancy model, and if you want to see it, it's in the notes. There's a video for that, so I don't need to do it again. But if you want to do this a simpler way, we're going to use stapplet. All right, so if you go to stapplet, and we are working on binomial distributions. I'll go ahead and zoom this in just a touch. There we go. Binomial distributions. And you'll see that it's asking for 2 things, N and P. So we better talk about what N and P are. So in our model, N is the number of trials. So you could say, oh, I think it's 5 or I think it's 10. Well, you're trying to guess how many questions out of 10 you're going to get right. So it's actually, N is 10. So we're going to write down N is the number of trials. Let me just write it here. N equals number of trials or attempts. And in this case, that is 10. All right. Then the probability is the probability of success on one try. In this case, if you go look at the questions, right, you can see that there are 5 possible answers, but only 1 is correct. So in that, we'll say the probability is the 1 correct answer divided by the 5 total answers, right? So it's 0.2. So I can actually go ahead and go to stapplet, this link right here, and I can set this up with 10 and put in 0.2 here, and then plot the distribution. And you can see how many would we expect. And we're kind of getting into this in the next class, but since we're here, if you were answering 10 questions and you have a 1 in 5 chance for each question, how many would you expect to get right? Oh, 2 of them. And if you look at the stapplet, that is the mean. So that's kind of a preview into the next lesson. Now you can actually float over the bars, and it tells you the probabilities of getting these questions right. So the probability you get 0 right is 10.74% or 0.1074. So now we're going to go ahead and look at the math involved in terms of getting these answers. So what is the probability that you get exactly 5 questions correct? So you got a couple options. I could just float over the 5. It's 0.0264. I could go exactly 5, and you can see it gives that to me right here. So, and it highlights the bar up there too. So calculate the probability of exactly 5, and we'll go ahead and put this in our notes. All right, so there's the probability of exactly 5. All right. What is the probability we get exactly 7 right? Now, again, I could try and float over the 7 bar, and it's visible enough I can do it, or I can just put the 7 in here, hit go, and you can see the answer. Notice how it highlights what I'm interested in. So I'll go ahead and capture this and put it in. All right, and put it in our notes. Right there. Okay. Now, what is the probability you get 7 or more correct? So there are a couple things you can do. You can actually highlight multiple bars up here, but you're going to see on the practice that we do later, that might be hard if the bars are really skinny because n is really big. So you can see here, it's telling me the probability that's 7 in 10. So when I highlight a bunch of bars here, what it does is it'll set your values here. So you're like, oh, okay, there we go. I want 2 to 4, but you can just change it to 7 to 10 down here. Notice it does want it to make sense. And it gives you the probabilities, in this case is 0.009. So between 7 and 10 is 0.009. And see how it writes the notation there in the less than or equal to. So it gives you a nice probability notation. All right. What is the probability you get 7 or less questions correct? Well, you could highlight here to 7, 0 to 7. And the nice thing I like about that is that you see that 0 is actually one of the possible answers. And we did have a couple of kids get 0 questions correct. Our highest number we had was 6, but usually it was around 5. Or, so the question said, what is the probability you get, I'm sorry, 7 or more. I skipped ahead, didn't I? 7 questions correct. No, that was 7 or more. Now we're 7 or less, so we're on the right one. 7 or less. So there are a couple ways I can do that. I can say less than 8, right? And notice the box doesn't change. If I said less than 7, the box is now leaving out the 7. So make sure that it makes sense. You can say at most 7, and that would count as well. So, and it'll give you the proper probability notation, because if I said less than 8, you're going to find out. Notice how it changes the probability notation there to match the appropriate symbol. So actually, I don't want less than 8. I'd rather have at most 7. I mean, you can, it doesn't really matter. So there are a couple of different ways to do that. So let's go ahead. Probability of at most 7. That's one way to answer this. And actually, let me go ahead and say less than 8. So less than 8. And I can also do 0 to 7 inclusive, like what's down there. So that works too. Whoops, that's not what I meant to do. Let me come back. There we go. Let Let me copy that. There we go. So less than 8. That is the same thing as at most 7. So really the tricky part here, because we have the stapplet, it's not so much about putting into the formulas here. It's more about understanding what cases we're talking about and the different ways you can word it. 6 or less correct. So that's very similar. 6 or less correct. That's less than 7. So I could do it that way, right? So that's 6 or less. You can see it there. So I'll get that. Probability of less than 7 is the same as 6 or less. All right, so that's one way to answer that. And then we could also do at most 8. I'm sorry, at most 6. All right, and you get the same answer there. And of course, you could always just highlight 0 to 6, and you can see that gives you, let me go ahead and put this in first. Or you could just be very specific and say 0 to 6. So if I go there, get that answer. So between 0 and 6, I'll just get this piece. So that one works as well. All right. And I'll put this on the side. There we go. So all of these are different ways of getting the same answer. What's the probability you get 8 or more? Okay, so we're going on the other side. That means more than 7, right? That would be one way to answer it. We're finding that's 0.009. At least, wait, 8 or more. Oops, that's not the right answer, is it? Hold on. 8 or more, so that means more than 7. All right, so now we're at 8 or more. So always double check your picture there. Make sure it makes sense. So probability of more than 7, which by the way is very close. If you're doing the pair deck, I think the multiple choice option was 0. On this one, go ahead and pick the 0. We could say at least 8. And make sure that's an 8. And we get the same answer. There we go. Put that in. So you're going to see if you look at this that I have a couple different ways to calculate these answers. All right, so last but not least on this particular piece is what is the probability that you get 3 or more questions wrong? So probability of 3 or more wrong would be, so if you get 3 wrong, first of all, there's one way you can do it. You could actually change, and some of you did this. You're like, oh, okay, so I'll just change the probability to wrong probability. Plot distribution, and then you say at least 3, and it will give you the right answer. All right. The other way you can look at it is if you get 3 or more wrong, that means how many could you get wrong? You could get 3 wrong, 4, 5, 6, 7, 8, 9, and 10 wrong. Those are all possible, which means how many right? The number of possible right answers. Well, if you get 3 wrong, that means you got 7 right. If you got 4 wrong, you got 6. And so you'll see that this will become that. So it's basically 7 or less correct. And we did that problem in number 7. So if you look up here, so the probability that x is less than 7, I mean, really less than 8, less than or equal to 7, I'll do it there, is that 0.9999, which we saw before. And where am I getting that number from? It's from here, right there. Okay, so that's giving me the answer. But again, I could have also plugged in the 0.2. All right, so then we went to the boards and we practiced on this here. So we're going to do the left side and then we'll do the right side. Airlines frequently oversell seats on flights because they know not everyone will show up. This is 100% true. The next part are kind of made up numbers, but anyways, the plane for the flight to Houston has 130 seats. They sold 140 tickets and expect 90% to show up. Are the conditions met? So we're going to say yes, and I'm going to tell you why. And they're pretty much the same for both sides, so I'm just going to go through this part once. So yes, each passenger should be independent of the other. The probability stays the same for each ticket or passenger, right? And let's see, independent, and there are only two outcomes. Shows up or doesn't show up. All right, so what is N and what is P in this case? So N is we know that there are 130 seats, so it's not the 130. It's the tickets that we're not sure about. How many of those are going to show up? So N is 140, which is the number of tickets. And P is pretty straightforward. It's 0.90, right? Because that's the probability a ticketed passenger arrives, right? Okay. And I can actually quickly set up this one. It's very similar. This one is 230 tickets, and P is 0.95. Probability that the ticketed passenger arrives or shows up, or however you want to write it. Okay, so now I'm definitely want to do these one at a time because I'm going to be setting up my stapplet. So I'm going to go back to my stapplet. And how many did we have again? We're over here. 140 and 0.9. So that's the first thing you need to set up. 140 and 0.9. And you can see, okay, it's much harder to drag here and get actual values because these boxes are pretty skinny, and it's going to even worse on the other one. So we're going to go ahead and find out what is the probability exactly 130 show up. So I could try to say, oh, where's 130? I don't know. See how hard it is for me to click? So you want to just go ahead and use these drop downs. So exactly 130, go. And you can see that it's 0.0646. So I'll go ahead and copy that answer. Probability of exactly 130 is, there we go. And hopefully it'll fit on my little dock. Maybe I'll just, actually, I think I'll just chop off the, it's okay. We'll have it overlap a little bit. All right. Then what is the probability less than 100 passengers show up? So we go in here, and we go less than. Luckily, that word is exactly there. Let's say 100. Go. And it's pretty much 0. All right. So it's pretty much 0. Less than 100. Copy. Put it in our dot. All right. So that's the probability of less than 100 showing up. Okay. At most 130. So at most 130. Go. And you can see, there you go, 0.9027. And it's nice because the words match. Whoops, wrong one, back here. So at most 130. And then what is the probability at least 131 show up? So at least 131. Make sure I answered that correctly. At least 131, yes. And oh, that's not at. No wonder I was like, that doesn't look right. At least. How did that switch? At least. There we go. That's what I remember the answer being. I'm going, that doesn't make sense. At least 131. Okay. And put that in. And then what is the probability between 120 and 130 show up? So you might be tempted to go 120 to 130. Problem is, it's, oh, wow, I hit it. Here I am saying how hard it is, and then I get it. So it's usually easier to come down here and do the 120 and 130, and it gives you that piece right there. All right, that was lucky. Wrong page. There we go. So there's 120 and 130, and you can see the answers there. Okay, so now we'll go ahead and set up for the other one. It's 230 tickets and 0.95. And now we're going to find out 212. So on this one, it's definitely, I mean, I guess I could float over it. There it is. 212. Or I could just put exactly, this is easier, 212. And you can see exactly the answer. And you see how skinny the rectangles are. So exactly 212. Did I set up the, yes, I did set up with 230, didn't I? Go ahead and that'll right there. 230 and 0.95, right? Yes. All right. Just making sure I'm putting the right answers. Less than 200. So you could try and highlight all this, but you can see I was a little bit off. So it's easier actually to come down here and put it in. And again, it's still pretty darn close to 0. So that's okay. Just go ahead and put it right there. And that's using the less than. I could have actually done it a couple different ways. I could have done it right here. I could have said less than 200. That's true. And there you go. It's about 0. So you got a couple options. But it's whatever you're comfortable with. There you go. There's less than 200. Both of those. Okay. At most 212. So there is a drop down at most 212. Put in the right number. Hit go. And you get that value. Put it in here. Then we've got our at most. And what is probability? At least 213. So at least, let's get that first. 213. And actually, I don't know if you noticed on some of these questions, I'm actually asking the complement of each other. So if you were to add in, I pasted that, there we go, at least 213. If you add 0.9585 to this 0.0415, then you should get 1. Same thing on 5 and 6 on the other side. Then finally, between 200 and 212. And you can see I get the 0.0415. All right, and I could have tried to highlight the box, but it probably would have been a little bit tricky. All right, and that is what we did in class, including our whiteboard practice for the binomial random variables.